Hi, Noel Chemists, Miss Rose. Today we're going to talk about Checkpoint 4, and on Thursday we're going to meet as a class. So, Checkpoint 4 is going to bring you right here. The first thing you're going to do in this checkpoint is you're going to be introduced to a slide deck. And this slide deck, in its most basic form, is how your project is going to look when it's all finished. So the first thing you're going to do is start with a title page, the name of your molecule, your name, chemistry, and quarter one. The next slide is going to be the history of your molecule. The next is going to be its chemical makeup, and we'll talk about that. What elements are in your molecule and how many of them. Then you're going to have either a drawing or a picture of the internet of your model. And then we're going to build models using molecular kits that we're going to deliver to your house. I'll show you how we do that. Talk about some properties of your molecule, some of its uses, abuses, and toxicities. What is its purpose? What has it been misused for? Does it have toxicity? Can its toxicity be reversed? And then the societal impact. How does it affect people and society and even the environment? And then finally, a works cited page. This is where you put all the links to all the websites that you use to complete your project, okay? So you're going to begin that, and you're going to continue researching your molecule based on the information that's on the slide, and you're going to be putting things in bullet form and also uploading images to every slide and using that works cited page to put the links to all of the websites you use to gather information. The second activity you're going to do this week is you're going to learn how to build a molecule by watching this quick video about how to build ethylene. So this video is a quick introduction to how to actually use the molecule kit. So let's take a look at this. It's very quick.
Remove your modeling kit from the box and separate the pieces by color and number of holes. For example, place all of the white pieces with 1 hole together and all of the black pieces with 4 holes together. Organizing your modeling kit will help prepare you to build molecules. Review the modeling kit key in your experiment. The key will tell you what element each piece represents. This is the key for the Lewis structure experiment. We can see from the key that the white piece with 1 hole represents hydrogen. The black piece with 4 holes represents carbon. The short and rigid piece represents a single bond. The long and flexible piece represents a double bond. And the pink paddle-shaped piece represents lone pairs. When you're comfortable with each piece, you're ready to start building molecules. Let's build ethylene, which has the formula C2H4. Ethylene has a double bond between the carbons and single bonds between each hydrogen and carbon. To create a double bond, gather 2 of the long, flexible pieces and use them to connect the carbon atoms together. Then create the 4 single bonds using the short, rigid pieces to connect the hydrogen and carbon atoms together. Congratulations! You've built your first molecule.
Okay. And there we have it. Okay. So now I'm going to help you fill in some of those blanks about how in the heck did she even know that? Okay. First of all, the molecule that she built is called ethylene. It's one of the molecules maybe that you wanted to pick. Here's its chemical formula, C2H2. Over the course of the past couple of weeks, we've been learning that carbon and hydrogen are two of the elements in the periodic table, that carbon symbol is C and hydrogen symbol is H, and we know that these are both nonmetals, and we know that there are 2 atoms of carbon and 4 atoms of hydrogen. These subscripts underneath the element tell us the number of atoms of that element. If it were just saying C with no number below it, it's understood that the number is 1. So here's ethylene, C2H4. So in order to build ethylene, you're going to need 2 atoms of carbon and 4 atoms of hydrogen. You may end up getting a molecular kit that looks something like this. And if you remove the top of the kit, on the inside is something we call the key. And you can see from this key here that carbon is a black ball with 4 holes, and that hydrogen is a white ball, whoops, with 1 hole. Okay? So, if carbon is a black ball with 4 holes, I need 2 of them, and hydrogen is a smaller white ball with 1 hole, I need 4 of them. 1, 2, 3, 4. Okay. We're off to a good start. But how do we hook these together? Well, we have to look at the chemical structure of ethylene to know. The 2 carbons are here in the middle, and they have these 2 lines between them, meaning they have a double bond. They're bonded to each other not once, but twice. Okay? And then off of those is the hydrogens. Okay? Take a mental image of this, because now I'm going to build it. Okay? I'm going to take my 2 carbons. I'm going to take these long bonding sticks. I'm going to put it into 1 hole, put it into the other hole of another carbon. This would be a single bond, but they're doubly bonded to each other. So I'm going to go ahead and build that double bond. Now, the reason we use the longer sticks between double bonds is simply because they can bend easier and overcome that distance, okay? Now we know we need 4 hydrogen, and the hydrogens are going to go off the holes left. So here's 1 hydrogen, and we know hydrogen just has the 1 hole. So far, that's what we have. Now we're going to do the second hydrogen. Now there's no more holes on this carbon. We've filled them, so we're on to this carbon now. And this is a molecule of ethylene. It has 2 carbons. It has 4 hydrogens. It has a double bond right here in the center between its carbons and single bonds with its oxygens. Let's take a look and just be sure that this is exactly how we want this to look. Oops, that is not exactly where we want to be. And there we are. Double bonded carbons, single bonded hydrogens. Okay. Now, I know that some of you have picked other molecules. So let me just, off the top of my head, say maybe one of you has picked melatonin. Okay. So melatonin, as we see here, its formula is C13H16 N2O2. I don't know if you can see that over here on this. So let's take a look at melatonin. So that means that melatonin has 13 of these black carbons. It has 16 of these white hydrogens. It has 2 nitrogens, 2 oxygens. And if we look on the inside cover here, it'll tell us that nitrogen is blue and that oxygen is red. So here is our nitrogens, the blue, okay? And here is our oxygens, the red. We know that the carbons are black and the hydrogens are white. So a molecule of melatonin, right, which we know regulates our awake and sleep cycle, is going to have black carbons and white hydrogens and blue nitrogens and red oxygens, okay? And we're going to have 13 of these carbons and 16 of these hydrogens and only 2 nitrogens and 2 oxygens, okay? The nitrogens are the blue, the oxygens are the red. And now what will it look like? But how do we put all those together? Well, we would type in melatonin structure. And then we would quickly see how we do melatonin. So I would go to images and I would pull it up. And these rings here, the carbons, they have not labeled, okay? And that's something that you'll frequently find. You won't necessarily see the carbons. So here we have it. Here's carbons in a 6-sided ring. This is carbons in a 5-sided ring. Here's your 1 nitrogen. Here's your 2 nitrogen. Here's one of your oxygens. It's double bonded to a carbon there. And here's another oxygen single bonded to the carbon in this 6-carbon ring. Anytime you see the 2 lines, it's a double bond like we have here in ethylene, okay? So you're going to see in this 6-sided ring, there's 2 double bonds, actually 3 double bonds. And in this 5-sided ring, there's 2 double bonds. And so anytime you don't see a letter, that's understood to be carbon. So here are where all of our carbons are, our 13 carbons. And if we count around, we'll be able to find them. Aside from the 6 in this ring, we would have, this would be 7 and 8, 9, and 10, and 11 and 12, and we're missing one somewhere here. Oh, here would be a carbon, okay? So there you have it. Here you can get a better look at that last carbon that's up here and a carbon that's out here, okay? In each of these places, we also have a carbon. Now, I'm going to make you up tiny bags, Ziploc bags, that'll have just what you need and enough sticks to make your molecule. And they'll just come all loose in a bag, and we can meet on Zoom and build them. And this will give you an idea of the ways in which these elements bond together to make molecules. Now, the other piece of this particular checkpoint, let me see if we can get there, asks you to start considering your presentation, which is coming up, okay, at the end of this month. So I'm going to ask you again to go over your slides here, make sure your information is in bullets, make sure you have an image or images on every slide, and then I want you to review this particular slide deck, which is going to be helpful for you. How will I be scored? And this gives you the rubric on oral presentation. It gives you some tips on oral presentation and what are some of the things that you'll be graded on. eye contact, pronunciation, volume, body posture, those kinds of things. The other thing, if you go back to the checkpoint, is that there's a rubric. And if you click on this, you'll be able to see the rubric and understand what the particular grades are. Remember, in this class, we want to stay between a 4.5 and a 6.5. But the 6.5 is really where we want to be. That's 100%. That's somewhere between the 6 and the 7 here. Consistent control of eye contact, good volume, pronunciation, body posture, emphasizing points, and making sure that your articulation is clear and that you are really maintaining the audience's interest. Then also, I'm going to give you an opportunity here to review 2 oral presentations. And here they are labeled 1 and 2. And then you need to decide using that rubric what grade you would give them and why. And you write your answer here. And that's the end of this checkpoint. Okay? We can meet again anytime in Zoom, and I can help you build your molecules. This is a really fun part of chemistry, and the kits will be delivered right to you, or if you're coming to WorkBar, I can leave the kits labeled right in WorkBar for you. So let's, when we meet on Thursday, really shore up which molecules you're adopting, and I'll have those kits prepared and ready for you. Great job, Noel chemists.